So here are just a couple things for you as you're thinking about solutions. The first thing is don't forget when an ionic compound dissolves in water, it forms those ions. Those ions unlock. Water is our most universal solvent, and actually it's called that. If the compound is ionic, it would form electrolytes. Now, some ionic compounds form strong electrolytes, like you see in picture 1. All the ions have come detached. Others form weak electrolytes, like you see in number 2. Only some of the ions become detached, and we're going to see that in our next unit when we do acids and bases. And then covalent compounds do not form ions. Their particles do not unlock. Those are simply little molecules in number 3 dissolved in water. So I just wanted you to be aware of that before we take a look at concentration. All right, so for concentration, mostly what we're interested in is how many particles are in there, in that solution. And there are a few different ways to measure concentration: grams per 100 milliliters or moles per liter. So we're going to take a quick look at that. So our first way to express concentration is a mass to volume percent. Technically, the units of mass and volume don't cancel out, but we still call it a percent. And so here is your equation. The mass of solute in grams divided by the volume in milliliters. Now, very important that you use milliliters. For many of our things, we've converted to liters, but for this one, you don't, and then times 100. All right, so here's a problem. Take a moment and look at this problem. A pharmacist needs to dissolve 4 grams of medicine in 2 milliliters of water to make 3 milliliters of solution. What would be the mass to volume percent? All right, well, the mass of the medicine was 4 grams. He's going to make 3 milliliters of solution. So simply the mass of the solute divided by the volume of the solution in milliliters times 100, so you get 133%. Here's another problem. You may want to pause the video here and try this one on your own. All right, how'd you do? 16.4 grams of calcium nitrate dissolved in 2 liters of water. Assume that the volume of the solution is 2 liters of water. So you would be using a volumetric flask like we did in the lab, but instead of being 100 milliliters like the one you used, it would be 2,000 milliliters or 2 liters. So did you set it up just like this? Did you convert your volume into milliliters and then multiply by 100? So hopefully you came up with 0.820 rounded to 3 significant figures. All right, another way to express solution concentration is mass to mass percent. All right. And this one, your units will cancel out. So you take the mass of your solute, again, divided by the mass of your solution, not volume of solution, times 100. So 2% milk, that's how we buy our milk, is a mass to mass percent. So that means that you've got 2 grams of fat in 100 grams of milk, and that's a 2% solution. You might buy 4% or full fat milk, 4 grams of fat in 100 grams of milk. So it's just another way of measuring concentration. Let's take a look at this problem. See if you can figure out how you would do it. Now, as you're taking a look at this, notice you only have the mass of the volume of the water. Don't forget the density of water is 1, so every milliliter of water weighs 1 gram. But you're not interested for your solution. You're not necessarily interested solely in the mass of the water. You've got to have the mass of the solution. All right, so how'd you do? Did you figure that for your mass of your solution, you had to add your water and the sucrose that was dissolved? Hopefully you did. All right. The third way to express concentration is molarity. And I know there are many molarity problems on homework number 7. I think it's 7. Yes, 7. And again, this is the number of moles per liter. And here is your equation. Now, keep in mind, if you take this equation, you can rearrange it. And I usually use big M for molarity. Big M times your volume. And I often just use liters because that volume has to be in liters. equals our number of moles. The other thing that we can do with this equation is that our volume in liters, because oftentimes you'll be asked to find that, equals our number of moles divided by big M molarity. Now, the great thing about this is when you have that number of moles in moles and you have molarity, that is moles divided by liters. Your moles are going to cancel out, and you're going to be left with volume in liters, which is what you want. All right, so here's just a couple ideas for you. I think I'm going to skip this next slide and go to a couple future slides because you've already seen this one before. All right, so no, we did one like this the other night. All right, here we go. If you dissolve 10 grams of iron nitrate in water to make the final volume 330 milliliters, what is the molarity of your solution? Of course, first you have to write the formula for iron to nitrate correctly and figure out how many moles are in it. Then what will you do? Well, you'll take your number of moles divided by your volume in liters. Notice you've only got milliliters there, so you would have to convert that. And there you go. So you've got moles divided by liters, and that is going to equal your molarity, 0.17, rounded to two significant figures, since 330 only has two significant figures. And then another problem I know you all are encountering is diluting a solution. And so the formula for diluting a solution is if we know the molarity and the volume of this solution, we could figure out if either the molarity or the volume of that solution. And those are really oh, sorry, that should be a 2. The questions in the homework and the review quiz. All right, so let's take a look. Notice your number of solute particles are the same, and how do we measure those? In moles, of course. All right, so here we go. So hopefully you took, and of course some of this was given to you, I do apologize. Hopefully you used that equation. You divided by your volume, your 3.8 and your liters cancel out. And so you come up with 2 times 0.88 divided by 3.8 equals 0.46 big M. That is the molarity of that new solution that you diluted down. All right, here's a second and final dilution problem for you. See how you would attack it yourself. All right, how did you do? Did you start with this formula? Did you figure out, now for this one, I always convert, when I'm dealing with molarity, I always convert my volume to liters so that I don't make any mistakes. You don't really have to for this problem because you can figure your answer in milliliters. So when you solve for volume 2, hopefully you took 0.15 times 0.1 divided by 2.5, and you got 0.006 liters or 6 milliliters. I hope this helps you as you're working through the solutions.